Did you get these down yesterday, all these notes? Okay. So this would be the top picture, iron ore. So if you've seen red soil before, especially Oklahoma has a lot of red soil, that's iron in the soil. That's combined with oxygen to produce rust. And that's what you're seeing. You can take out the iron though. And that's why it's called iron ore, because you can separate the minerals from iron and get pure iron from that. Mars also is red because it has iron in its soil. Your blood is red because of the same reason. Your blood contains iron, combines with oxygen to make it red.
Is it true that your blood is blue until it touches oxygen?
No, that's not quite true. I mean, it appears to be blue. It's an illusion though. Like you look at your skin, you see the veins, and it looks blue. People think your blood is blue because of that, but it's just the same as when the sky looks blue to you. It's because of refraction. The light goes through your skin and it bends, and only blue light escapes from your skin, and so it looks blue to you. But if you were to actually see your veins, it would look dark purple, dark red. It wouldn't actually be blue. But your blood, if it doesn't have much oxygen, is going to be a lot darker in color. It'll look dark red, purple, or even looks almost black. You had a really, really deep cut before. Have you noticed the blood looks really dark? You know, and that's because it's not much oxygen in there. When it hits the air, it turns bright red. So your blood goes from bright red to dark red, but it never is blue. It just appears sometimes to look blue through your skin.
Someone stepped on my fan a couple months ago, and my nails like purple. No, it's like perfect.
Yeah,
It's dark in the wind.
right. And so below the skin, you're gonna see some blue through your skin. That's like because the light is bending and it looks like it's blue, but it's not really blue. But as your blood degrades, because basically what you see below your skin is just blood that's piled up. When the blood is broken down, you get pigments like green pigments, you get yellow pigments, which can combine to make different colors. And so they can look like it's purple, but you don't get blue pigments from your blood, but you can combine, green and yellow make what color? Is green and yellow make a blue color? I think it does. Does or is it yellow and blue make yellow green? Is it the other way around? So it might look blue, but it's only because the light from your skin is hitting it and refracting. And that's why you see what looks like blue.
So if there's not enough like iron in the blood, what color would it just be, like a lighter?
Yeah, so if like you're on your skin or like your blood itself. Yeah, your blood would just be darker.
Darker?
It would look darker to you. Because more iron makes it brighter red. So it would just, now if you had less blood cells, which I guess would usually happen, if you have low iron, you usually have less blood cells. In which case it would look lighter if that's the case. It would look, yes, it would look more watery if because of the less iron you had less blood cells. And people who are low in iron look pale because blood gives your skin color, makes your skin look pink. And with less blood, you look paler because of that. And so if people who have anemia, they look very pale because of that. And also they usually crave crushed ice. And that's one sign. That's one sign that you have anemia, because like do you? Yeah. Do they have any way to treat it, or?
I do like iron.
Okay.
But I feel like make sure I do that so I don't have
Mm-hmm. But do you feel tired?
Yeah. My brain gets like foggy sometimes.
And that's why crushed ice helps. That's why you crave crushed ice with anemia, because it just helps wake you up. Cold water, ice helps metabolism get faster, and that helps you feel more alert. So everybody have these down? Okay, going to the next one. Don't worry about 12.3. We're not on 12.3. I'm just combining notes for other sections, but this is still 6.1. So non-metals, we were talking about metals yesterday, but today we'll look at non-metals. We mentioned this before. And actually, we already wrote down most of this, I think. So let's not worry about this for right now. Oh, so yeah, don't worry about these notes for right now, because we wrote down a lot of these already. The non-metals would be over on the right-hand side. So they would be starting in group 13 and going up to 18. So that that shirt tells you what a human body is made out of,
Um,
all the chemicals in the human
It
body.
only tells you down to phosphorus because you can't really,
So it says 6.2% potassium.
no, I think it's 0.6.
Oh, you know what, you're right, that is zero, yes, here we go.
1.5.
Yeah, so 0.2% potassium, 0.2% chlorine, 0.2% sulfur, 0.1% sodium. And that last one,
That's saying no peaches.
no peaches.
Right.
Yeah, I'm not sure what that's supposed to be. I don't know.
It says no peaches.
I'll have to- I can look really fast and see. All right, so hydrogen is a common non-metal. 90% of all atoms in the universe are hydrogen. Oh, trace elements. That's what it was
What's
after.
that mean?
It just means that other elements that are in very, very small amounts,
Do we have naturally occurring gold in our body?
not naturally occurring.
Oh,
But you can eat gold and you can have some in your body. But no, I don't know how you get gold in your body naturally.
well, I'm saying like one of the trace elements.
Yeah, I don't know. Like, now, again, you can ingest gold, but just on its own, you wouldn't have it in your body. It's not a common food product. It's expensive. But if you were to every day have gold-plated utensils, then you would have gold in your body if you use gold utensils, but it's not commonly used in homes, so you wouldn't have that. But people have Teflon in their body because Teflon is used to coat frying pans so much that people, because they use food products on Teflon, they've ingested Teflon in their bodies. And people have things like BPA and plastic components in their body too, because they drink water bottles with plastic. Or
What does BPA do to you?
well, it can cause cancer. So BPA is a chemical that acts like estrogen, which is a female hormone, but it doesn't work like estrogen. It disrupts the body. And so if you take a lot of BPA, you can have hormone disruption, either if you're male or female, and that can lead to cancer.
Doesn't, like, don't they find that in like the plastic surgery plastics, and it causes like severe depression? Like,
I haven't heard about that. It's like even like actually the plastic they insert in your body and keep it there.
Yeah,
Is it?
like the silicone stuff, like that they put in, like people like get severe depression.
Oh, wow.
Yeah, and it's weird.
So I guess it's the same kind of reason, right? It disrupts your hormones and
Yeah.
just, wow, that's bad. Well, I hope they're not going to use that in the future. I had no idea about that. But you probably have seen, I know about BPA, and you see it on, water bottles, they'll say BPA free because it's, people are concerned about that now. Yeah.
So are females or males more prone to like all types of cancer, or is it like more of a?
Well, there's a certain kind of cancer, that's more prone to certain people. Like males get prostate cancer, females get more breast cancer, ovarian cancer, uterine cancer. So, there's certain cancers that are specific to females or males, but on a whole, females are more prone to cancer than males are. So, but I mean, so yeah, it just depends on the kind of cancer you have, but females are more prone to diseases like that, like cancer and autoimmune diseases. Probably because they have, babies are foreign creatures to the body. The body knows that. And that's probably why women have more immune problems, because they have a more complex immune system, because the body has to be able to keep the baby in, even the body knows that the baby is foreign to it, the body has to know not to attack it. And it's more complex, and because of that, things can go wrong more easily. That could lead to things like cancer.
Do like antidepressants, like they actually work? I mean, I've heard that they like ruin your mental health even more.
Sometimes they can. They usually do more good than bad. So for most people, it's more helpful than harmful. But it is true. I mean, sometimes it can set you back and make you feel worse. In which case, once you stop taking it, you're going to feel better again. So it's not going to be, especially for teenagers though, there can be worse effects than people who are older. They don't always recommend antidepressants for teens because it can make you feel suicidal. It can make you feel a lot worse.
Isn't it supposed
So-
to be antidepressant?
Yeah, but for teens, it works differently than adults. And so it's scary for teens to be antidepressants because a lot of times it does make things worse for teens. But for adults, it's usually more helpful than harmful. So yeah, for a teenager, they're less likely to put you on antidepressants because of that risk. But it can help some people as well who are teens. But you would know in a few weeks if it's working or not, and you can get off of it pretty easily or switch. But yeah, if you took it for long term and it kept on getting worse and worse, and that could be really bad for you. But after a few weeks, you would know, and you could get off of it and you would feel better again.
Why is it
But-
that adults are more, like, it's not as bad for them?
Because after age 25, your brain is fully formed, but before 25, your brain is still developing.
Oh,
It doesn't feel that way. I'm sure, if you feel like your brain's fully developed, but you're still developing your brain until age 25. And so because of that, you're more prone to, alcohol or antidepressants can affect a teen's brain a lot more than people who are older. And that's why it's especially important, marijuana, alcohol, things that affect your brain will hurt teens a lot more than adults because of that.
I know that ionic and covalent are talking about the bonding, like, can you explain those again?
Oh, yeah, ionic and covalent. So we'll actually get to that later, but the short answer is that covalent bonds, they share electrons. And ionic bonds, they give and take electrons. But I don't want to get to that too much for right now. I didn't even mean to put that in there actually, but we'll get to that more in detail in chapter 9. So hydrogen here on Earth, most of it is found in water, but in the universe, most of it's found in stars, including our sun. Diatomic elements, we talked about this before, they're two atoms made of the same element. Hydrogen is very reactive, it's very explosive. They can use it to power cars, but and it's a very efficient fuel because the waste product is just water, which you can reuse and to make more hydrogen gas. But the reason why they don't is because it's explosive. And so they're concerned about that.
Can't you take measures to prevent that? Can you put heavy insulation around it, firewall?
Oh yeah, sure. You can definitely make it, there are ways to make it safer, that's for sure. But even with that, there's still a problem with fueling. Making it safe when you go to the gas station, you have to fuel with hydrogen.
Can you do something more of like, when you hook up an air tank, there's a little nozzle and you pull it and it releases a tiny bit of gas
Mm,
as you pull it off. And then you push it back on and it releases a tiny bit of gas. Couldn't you do it kind of like that where you put the hydrogen on, connect it and pull it off really easily?
That's a good idea.
Kind of like propane, except for easier.
That'd be a way to do it. I mean, I guess they're concerned, even gas stations, the gas is not nearly as flammable as hydrogen is. Even gas stations sometimes have fires and explosions. There's even one down the road, the 7-Eleven down the road had a fire a few years back. It was on 183. I mean, so it happens sometimes where they catch on fire or explode. So even if you're really safe, that can happen. And that is one thing they're concerned about. It's also probably political too. It's not just practical, it's just politics sometimes. But hopefully in the future they will look into that because electric cars are not our future. Electric cars rely on coal and they rely on hard to get minerals like lithium and rare earth minerals, which are not sustainable. And they hurt the environment too. So it's silly to look into electric cars. It's just not going to be what we need in the future. We're going to need things like fuel cells, which rely on hydrogen. Because hydrogen you can get from water. And so we have a lot of water in the ocean. It's very efficient. There's no waste besides just water.
Could you use water to power cars somehow?
Yeah, theoretically you could, because you could separate the hydrogen from the oxygen in the water, get pure
No,
hydrogen.
like put the water in a tank.
Yeah, in theory you could, because all you need is electricity to separate the hydrogen from the oxygen.
But then that would basically just be an off-brand electric car.
Well, you would, yeah, you need a small battery, but to separate water into oxygen and hydrogen, I don't think is very much energy. Not like you would have in a car to run it. So that actually could be a way. Because you did this in class, right? You took a 9-volt battery and
Didn't you
separated
say
water.
Didn't you say that took a lot of energy?
Well, the battery does run out pretty quickly, just the way we had it set up. But you wouldn't have to, just the way we had it, it was running continuously. And there was no resistor to slow it down. But there would be ways to have it more efficient. And it would be a lot less energy than running a car. Like a Tesla used a lot more energy to run the car than you would have for taking out the hydrogen from the oxygen. Okay, let's go on to this next one. Group 17, the halogens. They're all colorful. Halogens you can see as solid, liquid, or gas. Iodine is a solid silvery substance, but when you heat it up, it turns into purple gas, which you see down here in this picture.
Are these non-metals too?
These are all nonmetals, yes. Mhm. You might have heard of halogen light bulbs. This is top picture right here. So halogen light bulbs contain some of the halogens. They contain halogens like bromine and iodine. The halogens form salts with metals. So chlorine forms a salt with sodium to make sodium chloride, which is table salt. Bromine also forms salts. So these have distinctive colors, as you can see. Green for chlorine, bromine is orange, iodine is purple. And they have distinctive smells too. Chlorine, you're all familiar with that smell. It's a very strong odor. And then iodine and bromine have similar odors to chlorine. Fluorine's also in this group, and it's the most active of all the elements.
What does it do?
Fluorine is used in glass etching. It can dissolve glass. You put it with hydrogen, you get a very strong acid, which can dissolve glass. And then even a small amount of it could be fatal to you if you were to have it fall in your body, because it would go into your bones and basically just destroy your whole body. It would just start to dissolve under your skin. So it's really dangerous because you don't see the effect of it. You can have a small patch of skin that's affected and you think, well, that's not a big deal. It's a small patch. But the fluorine goes below your skin into your bones and basically just destroys your body from the inside out. And so even a half a cup of it, that if you were to spill any, it would be fatal because it would just destroy your organs. So it's a very, very, one of the most dangerous chemicals that we have because of that.
So like the fluorine that like dentists use for like to clean your teeth,
Mm-hmm.
how much fluorine?
Okay, so that's a good question because there's fluorine and there's fluoride. And so fluoride is a stabilized version of fluorine. And so chemists use fluoride, which is stable and not dangerous. But fluorine is not stable and it's very dangerous because of that. So yeah, it's very safe what you use in the dentist's office because it's a stabilized version of fluorine. So it's not very reactive at all. It's not very harmful to you. So as far as we know, fluoride is safe in small amounts. It's in all our toothpaste, it's our water supply. So it's not harmful to us.
So does it just like clean?
Yeah, it replaces, basically what it does is it replaces the elements in your teeth with fluorine. So the fluoride is meant to have a chemical reaction with your teeth and remove a weaker element and go in place of that weaker element to make your teeth stronger. So basically it's just creating new chemical bonds in your teeth to make your teeth stronger and less prone to cavities.
What does it combine with at the dentist's office?
Well, so your teeth are made out of sodium apatite. and it reacts with the sodium in your teeth.
So it's pure fluorine when you're using.
Well, it's not pure, no, well, it's fluoride. And so it's a stabilized version of fluorine.
What's in the fluorine? Like,
What's it, fluoride? I mean, it's fluorine, but it's been stabilized. And so
but with what?
with another electron. So elements become stable with electrons. And so it's actually fluorine -1. And that makes it stable when you add one more electron of fluorine. So I mentioned hydrofluoric acid used to etch glass. So fluorine, hydrofluoric acid can be used to dissolve glass. As we talked about, fluorides are added to your drinking water in most cities, and that's just used to reduce cavities. And that's the main purpose of fluoride, is to combine with your teeth to make your teeth stronger and less prone to cavities, because cavity is a hole in your tooth. And so this helps reduce those holes. And most toothpaste products are made of sodium fluoride. Chlorine is put in the water too in most places. Chlorine is used to disinfect water. And then you can find chlorine in bleach, which is used to widen things. Bleach can be used to widen hair, to widen food products like flour or paper. And then bromine is used in cosmetics. So any orange color you have in cosmetics, it comes from bromine. Come in. This is 10th grade.
Good morning, guys. I need Ryan. Is he in here?
He already left.
Very well.
Oh, he left? Okay.
Yeah,
I thought he was still in here. All right, thank you.
that's weird. When did you last see him?
You want third period?
Well, yeah, he was sitting with his sister like right there.
Oh, okay. Huh, that's weird. All right, I hope everything's okay. And of course, chlorine's also put into pools to disinfect the pool water. It kills bacteria.
So if you swallow chlorine water, is it like?
Well, I mean, a little bit's not gonna hurt you because it's so dilute. You know, the amount of chlorine in the pool is a small amount. It's not gonna be enough. Of course, if you drink a lot of it, that's gonna be, you're gonna feel sick. But the amount that we have in the pool is so small, it's not gonna really be harmful if you just drink a little bit of it.
Except after they shock it when a little kid takes a dump.
Well, that's true. I mean, if you're, yeah, right after, if you treat the pool, that is more dangerous than other times. Yeah. You shouldn't be in there at that point. But yeah, but after you've treated the pool and after you've let it sit for a while, it's so dilute, it's a little bit's not gonna hurt you.
It's terrible when you're like, you have the chlorine like in a cup or something to like pour it in the pool and you like breathe in the fumes. and, like,
Oh,
literally,
yeah.
It's crazy.
That's really bad for you. You can even go to the hospital for that. I mean, if you just breathe in chlorine or bleach, that could be enough to just make you feel so lightheaded you pass out and you have to go to the hospital to get treated for it. So even the fumes can be deadly if you're in a small space, especially. Bromine and chlorine we get from seawater, from the salts in seawater. Iodine, as I mentioned before, it is a silvery non-metal at room temperature, but you heat it up, it turns to this purple gas. Yeah, it's really pretty.
Is that why they can use saltwater pools? Because it has both bromine and chlorine in it?
Oh, so that's a good question. So they can use salt because salt kills bacteria very well. Salt's one of the best ways to kill bacteria. So not many things can live in salt water. Most things die with salt. If you learn biology class, osmosis makes cells shrivel up with salt water. And so the cells just can't sustain life because they lose too much water. So that's why you can use salt instead of chlorine in your pools.
So why isn't salt used more? Is it just so expensive?
Yeah, I mean, people just prefer chlorine. But yeah, I know people who use salt in their pools and it works really well. So you can definitely use that instead.
We use salt in our pool and it doesn't even taste like bad. I think we do
Mhm.
like half salt or something else, but it's not salty at all.
Mm-hmm. Yeah, it's kind of strange. Like it kind of feels different to me. Like when I'm in a salt pool, like you can tell, like it's
like
the water
thicker,
feels
it's, like,
different.
thicker.
Yeah.
It's thicker, and chlorine is just like,
Dry.
it's also when you go underwater in chlorine pool, it's like foggy kind of.
Right.
Yeah.
Mm-hmm. But yeah, there's a sea over in the Middle East called the Dead Sea, and it's called that because nothing can live there. It's just way too salty for anything to live.
Wait, didn't scientists find something up with
Oh yeah, they
lightning?
did actually find a few bacteria that can survive there. But besides those little bacteria, a few bacteria, nothing. Most bacteria will die immediately in salt water. But they did find a few that could survive. But even in hospitals, they're looking at using salt to treat bacterial infections, and because it works so well.
Salt and ice.
Yeah, I mean that would kill. I mean that would kill your bacteria. That's for sure. I mean, it hurt your skin, but it would kill anything that's gonna infect you. So iodine sublimates. It goes directly from solid to gas. It's one of the few things that does that. Besides dry ice, it's one of the few natural things here on Earth that we see that sublimates and goes straight from solid to gas. Iodine is an important mineral for our body. We need it for producing thyroxine, which makes the thyroid hormone. And if you don't have enough iodine, your thyroid gland works too much and it swells up and you get this big, it looks like a basketball in your throat. Your throat just swells up really large. It's not common at all over here, but in other countries, like Africa, where they can be malnourished, it's more common in those places. But here we get iodine from salt. They add iodine to salt. It's probably what you've seen. It says iodized salt because iodine is important in our diet, but we get plenty of it because we all have salt in our food. It's hard to escape that. And if you take new salt, that is basically pure iodine, potassium with iodine. Does everybody have this down? And then acetine is a very rare element. It's radioactive. You can see it's glowing green.
Looks like algae at the bottom of an ocean.
What is algae?
No, it looks like.
Oh yeah, it kind of
algae.
does look like algae, doesn't it? A lot of things that are radioactive will glow different colors. So those are all group 17 elements. They're all nonmetals. Noble gases, last group, group 18, they're stable and they react very rarely with other elements. The only reason why elements react is to become more stable. Because they're already stable, they have no reason to react, and so they don't. It's very hard to get them to react with anything. That's why they're called noble, because noble means high class. The nobles are the kings and the queens, and they don't mix with the common folk. They don't mix with other elements. They're on their own. So they are used in chemistry because they don't react with other things. So you can have a room filled with argon and you can keep something from tarnishing or rusting because it's not going to react with anything else. They glow under electricity, different colors. Yeah, we looked at a couple of them. Yeah, we looked at neon, helium too. And then I showed you krypton. There was that fluorescent tube that I showed you, that krypton in it. So neon signs use noble gases to make the different colors that you see. And then there's a few groups that are groups 13 through 16 that have metals and metalloids in them. So metalloid is an element that has both metallic and non-metallic properties, as we talked about before. And groups 13 through 16 are called mixed groups because they contain metals, nonmetals, and metalloids.
Is that a waffle?
It looks like a waffle. That's a computer chip. And computer chips are made out of silicon,
Oh.
which is a metalloid.
Although I don't mind.
So metalloids are common or very useful in electronics when you need circuits to turn off and turn on at certain times. Be sure if you haven't already that you have a periodic table that has that colored, that you have a color periodic table with you for your own, which shows metals, metalloids, and nonmetals. So if you haven't, or if you lost yours, be sure for the next test that you already have that ready for you, because you're gonna need to have it colored to show where each section is. Group 13 is a boron group. So it contains boron, which is used in borax. It is used to kill germs. Oh, sure. Well, sorry, I lost it. Let me see. There you go. Aluminum, which you can see in this middle picture right here, it's the most abundant metal in our crust. It's useful, it's strong and light. The other elements on there, gallium, indium, thallium, are semiconductors. Gallium melts in your hand. It melts about 85 degrees.
That's awesome.
Mhm. I have some that I need to print out and show you all sometime.
Does it freeze back up when you take it off?
Yeah, it does. It's actually hard, especially in the wintertime, to get it to melt in your hand because your body temperature is 98 or 96 or maybe 95 degrees Fahrenheit, but your hand is usually colder than that because your skin will be a lot colder than 98 degrees because the top layer of your skin is dead cells. And so those cells are not living cells. So that's why you can have your skin a lot colder than 98 degrees. Your living cells are below that surface and they're at 98 degrees, but your top layer is not. So lots of times it's hard in the winter time to get it to melt in your hand because your hands are usually about 60 degrees or so.
How are the temperature zones accurate?
Oh, because it goes below your skin surface. It's a laser beam or infrared beam that goes below that first layer of skin.
Clearly not. It gives me a temperature of like 85 if it doesn't say.
Yeah,
low.
like that's not the best temperature gauge, that's true. I mean, it's supposed to go lower into your skin. It doesn't get as low it's supposed to go. So if it reads a low temperature, it's not getting low enough to get to your blood vessels.
For aluminum, I've heard some people say
Aluminum, yeah, that's how the British pronounce it. Yeah, so there's a few chemicals that there's a British pronunciation and it's not wrong. It's like tomato versus tomato. I mean, you could say it either way, but yeah, aluminium, I think they actually add an I to it. I think the British will spell some things differently. Like they'll spell sulfur differently as phosphorus. I think they spell aluminum differently too over there. So we have these down? Group 14, this is the carbon group. So all of these ones, as we've learned about before, have 4 electrons in the outer shell, but they're all have a wide range of properties in this group. So carbon is the nonmetal. Carbon can look like a black powder. So charcoal is carbon, coal is carbon, but also diamonds are carbon. The lead in your pencil is made mostly of carbon. So graphite, which is basically the pencil lead, is carbon in these sheets that can fall off onto your paper and create a mark. But diamonds are made, you can see right here, the carbon atoms are arranged in hexagons in tetrahedral arrangement, and it's very strong. And diamond is the hardest naturally occurring element. So other elements, silicon, germanium, those are metalloids. We mentioned silicon is used in computer chips. And then tin and lead is also in this group, and they're metals. Do you have a question or? That's right. Okay. So carbon, it has a wide range of forms. So as I mentioned, it can be coal, it can be graphite in your pencil lead, it can be diamonds, it can be soot. The different forms are due to the atoms arranged in different ways. And that's what an allotrope is. An allotrope is a different form of the same element. So a diamond and coal have the same element. They're both pure carbon, but the atoms are arranged differently, and that is what produces the different arrangements and different properties. Next test, I'll take up your notebook and give you a notebook grade for this quarter. And the test will be over 5.3 and then chapter 6. And chapter 6 is not going to be very long. It's mostly all chapter 6 what we're doing right now. Basically, to get a diamond, you just take coal and put under a lot of pressure, and heat and pressure changes the atoms arrangement to create what you see as a diamond.
Have you ever seen like you take like coal and you put it in like peanut butter or something? Does that work?
I think that's a myth. I think that it's just like a hoax that they had, because I've seen that before on YouTube, and I've seen people try it and it never works. And so I think it's just it was just a joke that people, but I don't know how that's possible. But on Mythbusters, they tried that before and they couldn't get it to work.
I
So
like that show. It's fun.
yeah, it's a good show.
I like when they blow up cement trucks.
They're really proud of that one. But you have to have an explosion. Basically, you have to have a lot of heat for it, and a lot of pressure for it to turn to a diamond, which you can't get from peanut butter in a microwave. Let's not worry about this one. Okay, silicon. So it's the next most abundant element in Earth's crust. Oxygen is the most abundant element, and silicon is next in abundance.
Wait, what's the next?
Oxygen is the most abundant, and silicon is next in abundance. Silicon dioxide is sand. And you can melt sand and turn it to glass. So basically glass is the same as sand as far as its element goes. It's just that it's a combination, or it's a rearrangement of that element into a different pattern, which creates different properties.
What's the person doing with their?
Oh, that's actually just how the glass was produced. They just had the glass hardened that way. It's just an artistic glass where you can just put your fingers in it and hold it that way. And this right here is a glass blowing, where the sand is melted, and once it dries or once it cools, it'll turn into glass.
Is that like super hot?
Yeah, it's very hot. Yeah.
So you like test it?
Yeah, you'd burn your hand really badly. You get, yeah, 3rd-degree burns. It's very hot. Yeah, if you just touch it, just like, it's a little hotter in the oven, you know, it's about 2,000 degrees or so. So it's incredibly hot. Yeah, it'd really hurt you.
Could you melt a glass pan in a home oven?
Not in a home oven, no, it's not, it doesn't get that hot.
So is like resin, we have the same components that glass and sand?
Resin is from trees, I believe, which is, you know, like sap from the trees. So I don't think it's the same as glass. Let me see what resin's made out of. Are you talking about resin or rosin? Is it,
Like RESIN.
okay.
Wait, isn't that just rosin?
No, they're different. Yeah, rosin is a white powder.
It makes stuff sticky.
Mhm.
Can't it also be hard?
What, rosin?
Yeah.
It can be
Well, it's basically just a powder, like, so it's solid.
like you,
Well, no,
you
I'm
can
saying
get it,
like
there's
a
like little,
part.
like when it's in crystal form, it's kind of like yellowy, but it's most like when you grind it down, it's white.
Well, except I use a chunk of rosin for vinyl.
Mhm.
but
Yeah,
Some are green. I've seen a blue one. I've seen brown ones.
yeah, so they can be a chunk. Yeah, that's right. They can be. Yeah, it comes from plants, it says. It's just like,
And is that why they make like UV resin too? Cause it just like brings a UV.
UV resin. I haven't heard about that. What'd the UV resin be?
It's like the same thing except for instead of like letting it like cure or whatever, you just put it under a light for like 5 minutes or whatever and then it starts.
Oh, okay.
Oh, like this. That's drying blue stuff.
It's like turned into like a plastic glass.
Okay, interesting. But yeah, it's not the same as glass at all, though. It's a very different compound. Okay, we'll stop here for today. On Monday, we'll finish up this section.
How many sections?
Oh, it's just all this one sections. We're on 6.1.
This is super random, but
Can you do what?
can your teeth burn?
Can your teeth burn?
Yeah.
Oh, they definitely can. Now, you need to have a high temperature for that to happen. But